Solving for problem 380, homework number 4. A river passes over a weir fully drowned, and as a result, the height of the river changes. And the find is the force of the river on the weir. So, what we know from the sketch is V1H1 and V2H2. So from conservation of mass, assuming that the flow is steady, incompressible as usual, all the usual assumption, conservation of mass, gives us that minus rho V1 BH1 is plus rho V2 BH2 is equal to 0. Or in other words, V1H1 is equal to V2H2. Now, to get the force of the weir on the force of water on the weir, we consider the following control volume, which shouldn't surprise you. It's basically the entire domain with H1 the height of water here, H2 the height of water there. I forgot the normals, so I have N2 and 1, and then in terms of forces, what forces are we considering? We're considering the force of the water on the left of the control volume, so upstream of the control volume, onto the control volume. So that's actually, let's draw it more where it should be, FP1. The force of the water downstream of the control volume, that's FP2. I have the force of the weir onto the control volume, which is minus F weir. That's the force I'm looking for. Obviously, also I have in terms of inertia, I have velocity coming in, V1, which is opposite to N1, the normal to the control volume, N2 is the normal of the control volume at the outlet, and I have velocity V2. So to write my conservation of momentum, d dt integral over Cv of rho v dv plus integral over Cs of rho v too close from this thing, rho v I apologize for that, and dA is equal to sum of the forces. Because the flow is steady, this is equal to 0. The flow is also frictionless, so there is no friction at the bottom. So we are looking at the integral over CS1 of rho V1 dot N1 dA plus the integral over CS2 of rho V2 V2 N2 dA, which I'm going to express right away, and that's the v1.n1 is negative, so I have minus rho v1 square h1b plus rho, now v2 and 2 is positive, so v2 square h2 and 2 sorry, I'm having some issues with my stylus, h2b, and that's equal to minus the force on the wheel, oopsie, forgot vector I, assuming that we have I like this, minus force of the wheel plus rho g h1 square over 2 bi minus rho g h2 over h2 square to bi. And so with this in mind, we can now factor everything and get that F wheel is equal to the contribution of the hydrostatic pressure. So it's 1/2 rho g b h1 square minus h2 square minus rho so if I'm going to write it this way, it's going to be minus rho h1 b v1 square h1 divided by h2 minus 1, and that's my answer. So what do you see here? You see that the second term is this part of the second term is positive, and there is a minus, so that the force is actually smaller than the force on just due from hydrostatic forces.